we have the function f of x equals x squared plus 3x minus 5, and we want to calculate f of 2, f of a plus 3, f of x plus h, f of x plus h minus f of x divided by h. That gets a little bit compressed down here. And we proceed. Okay, so f of 2, x, we have this expression f of x here, we have the expression f of 2 here. X has been replaced by 2, so every x needs to be replaced by 2. When we do that, we get the expression you see here, and this is very straightforward, I think you see it. And we evaluate this, and I believe we get 5. 2 squared is 4, 3 times 2 is 6, 6 and 4 is 10, 10 minus 5 is 5. Okay, well, that's very straightforward, and I'm sure everybody gets that. Okay, let's do f of a plus 3. Now, once again, x has been replaced by a plus 3, so x has to be replaced by a plus 3 throughout the definition. So we just follow that. X squared becomes a plus 3 squared. 3x becomes 3 times the quantity a plus 3, and the negative 5, of course, is a negative 5. Now, I say, etc. We can expand this and collect terms and simplify in a way that you don't need me to show you. Okay, so that simplifies in any case. Okay, now, we do f of x plus h. Well, it's the same thing as like f of a plus 3, except everything's a symbol. We're replacing x by x plus h. So what do we get? Well, if we replace x by x plus h, x squared becomes x plus h quantity squared. 3x becomes 3 times the quantity x plus h, and the minus 5 is not affected. Now, I'm going to go ahead and expand this, not because you don't know how to do it, but because I'm going to use it in a minute. X plus h squared is x squared plus 2hx plus h squared, just using the special product. But if you don't know that special product, well, you should, and you need to. But you can always multiply that out using the distributive law. You're going to get the same thing. And distributing 3 through the x plus h, we get 3x plus 3h. And then we have the minus 5. And we have a couple of x terms that we can collect. We got a 2hx and a 3x. So we have our x squared. It's the only place x squared appears. X appears here and here. So we factor x out, and we get 2h plus 3 multiplied by x. And then we have our 3h and our plus h squared. And I don't know what happened to the minus 5, but it should certainly be there. Okay, well, I sneaked it in there. You know it's supposed to be there, so. In any case, there it is. Okay, now we go to this expression. F of x plus h minus f of x divided by h. Now, I did ask you one step just to do f of x plus h minus f of x. So let's just see what that is, and then we're going to get that expression over h. So we just got to put an h in the denominator. Okay, well, f of x plus h is what? Well, we saw up here that it's x squared plus maybe I have something wrong there. Let me stop a second. Okay, sorry, it's getting a little late in the afternoon, and I was looking for this expression, and I saw this. Of course, this is just what we get when we substitute the x plus h. It's this. So just doing the substitution, f of x plus h is this, as we saw up here before we simplified it. We'll simplify it in a minute. And then we subtract off the expression for f of x, which is just x squared plus 3x minus 5. So we get quantity x plus h squared plus 3 times the quantity x plus h minus 5, just what we got up here, minus the quantity x squared plus 3x minus 5, which is just our expression for f of x. Now, we put all that over h, and I expand the x plus h squared and distribute through the 3 times the quantity x plus h, and I get what you see here. Now, there's some circles on this, and some of the plus signs are not real clear, like this one seems to have been obscured a little bit. But what we get is, from here to here, is just what we got up here. wasn't written that clearly up here. It's x squared plus 2xh plus h squared, which again we get from squaring x plus h. My plus, again, make sure we see that's a plus, 3x plus 3h that we get from 3x plus 3h minus 5, minus the whole quantity, x squared plus 3x minus 5. But of course I distribute that negative sign through here and get negative x squared minus 3x plus 5. Then the x squared matches up with the x squared, positive here, negative here, so that goes away. The plus 3x and minus 3x, same thing. The minus 5 and the plus 5, same thing. They add up to 0. We have positive and negatives matching up and adding up to 0. I don't like the word cancel, but some people would use it and say that's what happened to those terms. Okay, then what are we left with? We're left with this term, the 2xh, this term, the h squared, and this term, the 3h, which is maybe a little hard to read again because of the circling. And that's all divided by h. Well, when we divide by h, the division by h distributes over the addition, because division by h is just like multiplication of 1 over h, and that would distribute, so certainly the division by h distributes for that reason. So we get 2xh over h squared over h, 3h over h. Well, h goes into 2xh, giving us 2x. H goes into 3h, leaving us 3, and then we have a plus h. And I'd like to correct that if I could find the right color of chalk, or just make that clear. Somehow we got a drip down the side of the board here. And hopefully you can read that, but you can easily verify if you just write it all out yourself that that's 2x plus 3 plus h. This is a very common type of simplification that does occur when we start getting into the idea of calculus, of tangent lines and derivatives and rates of change, instantaneous rates of change. We'll see how that works a little bit later. This expression here has a specific name. It's called the difference quotient. Okay, it's the difference between f of x and f of x plus h, where h is generally considered to be a small quantity. And then we divide by h, which is, of course, the difference of the x quantities. It's actually a rate of change quantity. It's the rate of change, the average rate of change of f of x between value x and value x plus h, because here's the change in the value of f, and here's the change in the value of x. We divide the change in the value of the function by the change in the value of x, and we get a rate of change, and we call that a difference quotient. We generally consider h to be a small quantity that approaches 0, and the difference quotient then approaches what we call the derivative of the function, the instantaneous rate of change. Now we're going to talk about this in detail. I'm just giving you a little preview. If h approaches 0, then 2x plus 3 plus h approaches 2x plus 3. If you've had a little calculus, you can easily verify that the derivative of this function is 2x plus 3. So we've kind of proven the derivative of this function. But if you're not seeing this for the first time, haven't had any calculus, you can ignore the talk about the derivative. But the idea of a difference quotient is very important and wouldn't hurt you to store it away now. You're going to see it fairly soon.